Hi, welcome to this platform for Sensor Academy, either the YouTube channel or the Facebook page. If you are watching this on our YouTube channel, kindly hit on the subscribe button, turn on that notification bell in order to get notified when next we post a new video. If you are watching this on our Facebook page, kindly leave a comment, share this video, tag that GCE candidate or a grade 12 internal candidate awaiting for an exam, as this may serve as the right platform and inspiration for an exam preparation. In today's brief tutorial, we are simply going to talk about a topic in physics, particularly science paper 1, which is going to be from section B. We're going to talk about electricity, as we can rightly observe, an electric circuit. We're going to use a 2023 grade 12 November internal exam, question 7, and on A, the question says, what charge is acquired by a material that loses electrons by rubbing? So this is more like static electricity, which is going to talk about static charges. As a material is being rubbed, as the question says, acquired by a material that loses electrons. As the material is being rubbed and is losing electrons, it acquires an opposite charge. In this case, as it loses electrons and is being rubbed, it's going to acquire a positive charge. So an answer here is going to be a positive charge. Then B, give one natural occurrence of static electricity. So when we talk about static electricity, of course, we're trying to talk about things in everyday life that are applicable, such as combing through hair, as when someone is combing their hair in a dry, humid condition, the charges can form between the comb and the hair. And also, an example can be a static, maybe clean, and sometimes we can be able just to talk about lightning during a thunderstorm. It's a very good example of static electricity. So here I'm going to say lightning. Lightning through or lightning under or during a thunderstorm. So figure B7.1 shows a circuit diagram. And we've got the resistors, where we've got this one and the other two. So this one and this one are connected in parallel because this one is in the upper line, this one is in the bottom line. But this one is in series. So to find the total resistance, we will be able to ensure that we first calculate the one for the combined resistance, which is between these two which are in parallel, then come and add to this one. And then this one, which is an A, refers to an ammeter, an instrument in an electric circuit that measures the movement or the flow of current. And then for 24 volts, we're trying to talk about the voltage measured by a voltmeter. 1. Define resistance. Resistance is the measure to the opposition of the flow of current in the circuit. It is the measure of the opposition to the flow of current in an electric circuit. So I'm going to say this is the measure of opposition to the flow of current in the circuit. So this is the measure of opposition to the flow of current in the circuit. And resistance is usually given in ohms. 2. Calculate the total resistance in the circuit. So to calculate the total resistance, we're going to simply find the combined resistance between 3 ohms and 6 ohms. The answer we're going to get, we're going to add it to the resistor that is connected in series. So we're going to say total resistance equals to R1 multiplied by R2 over, we're now going to say R1 plus R2. This formula is only suitable if 2 resistors are connected in parallel, as observed between 3 ohms and 6 ohms. So here we're going to replace, so R1, we can say 3 ohms multiplied by R2, we're going to say 6 ohms. Over, this is going to be 3 ohms, and then plus, this is going to be 6 ohms. So total resistance is going to be 3 times 6, we're now going to get 18. Ohm times ohm, we're going to get ohm squared. Over, then here we're going to say 3 plus 6, this is going to give us 9 ohm. So I'm going to say 9 here, 1, 9 there, it's a 2. Then this ohm into ohm squared, we're going to remain with a single ohm. But this is not the answer. It's the combined resistance between the two. So to find the total, we're now going to say, therefore, the total resistance is going to be equal to, that is, this 2 ohm, which is here, plus the other 2 ohm. So this 2 ohm is the one that I found here. Then this 2 ohm is the one I'm picking, which was in series. So the total resistance is going to be 4 ohms. Having done that, it simply means we've understood the task of handling a question where it involves 2 resistors connected in parallel with 1 connected in series. You firstly calculate the combined or effective resistance between this one and this one, which are in parallel. You get 1 resistance. Then come and add to the one which is already in series, because resistance in series is always the sum of the total resistance. So our total resistance is 4 ohms. Then we move on to Roman numeral 3. What is the current in the circuit? So current in physics is given by, that is voltage over resistance. Then we can come up with our data. So current is the question, and for the voltage, we're going to pick it at the top of the battery, which is being displayed here. So this one is 24 volts, and then for the resistance, we're going to find that we are finding, which is a 4 ohms. We're going to substitute our data into the correct formula by dealing with units at each and every stage in order to ensure that we signify that we really know what we're trying to solve for. So I'm going to say current equals the voltage is 24 volts over the resistance is 4 ohms. So current is now going to be 4 here, 1. Further, it's going to be 6. And current is measured in amperes or amps, abbreviated as A. So you can say current is 60 amps. I hope you find this video very much beneficial, and I hope it helps you to prepare adequately and puts you in the proper direction for an exam preparation. Under our program, we've got reliable online lessons in mathematics, biology, science, English, and civic education, which goes at only 100 kwacha per month. If you are a GCE candidate trying to look for an institution you can rely on for online lessons, kindly contact us through the number in the description of this video. Ensure that you reach out so that we can help you in the next 1 month and half that is remaining before the actual final exam day. I hope you will be able to pick a paper or something that at least you can really reflect the lesson on and clearly be able to develop self-reliance. This remains your tutor, Mr. Sensor from Sensor Academy School of Tuitions. Till the next time, it's a very good plan.